Hello, welcome to Tech Foundation. I am Eric Obin, aka Professor. This is the first episode of the C++ 101 tutorial series. Now, in this episode, I'm going to build a foundation for the series. Since I don't know the background of my audience and I intend to reach out to absolute beginners, I am doing first refresher tutorials on introduction to computers. The aspects I would tackle are those that will be relevant for my future episodes. Now, if you are an absolute newbie and you want to learn more about computers, then I would suggest you get for yourself an appropriate material because I am not going to dive deep into what is a computer or into computer systems. However, if you are a pro, then you can skip this particular episode and wait for the next one. Programming involves computers, so let's do a quick review of what a computer is. A computer is an electronic device capable of executing what we call instructions. Now, instructions are mainly commands that tells the computer what to do. So take a computer as a generic machine that can become something you want by just asking it to be. For instance, with a word processor instructions, your computer behaves like a typewriter. With a media player instructions, your computer behaves like a home theater. Now, if you feed in a gaming instruction, then the computer becomes a gaming console. That is quite amazing, and this is what we intend to do by the end of these lectures. Every computer can perform 4 basic functions. It can accept input in the form of data or commands. It can process the input or the commands. It can output information or data. And finally, it can store information and data. Now, usually we blur the distinction between data and information. This is because it is not much of a big deal. Most often, what we call information becomes data for another process. However, to clarify, information is a processed data. Computer is made up of 2 major parts. We have the hardware and the software. Like a friend said, the computer hardware is the part of the computer you can boot. That's funny. So the physical part of the computer that you can touch is what we call the hardware. And the aspect that involves instructions is called the software. By function, we can classify computer hardware into 4 main parts. We have the input hardware or devices, processing hardware or devices, output hardware or devices, storage hardware or devices. Now, some devices can have multiple functions. For example, modern photocopier machines can scan as input devices and also print as output devices. If you have a laptop that is equipped with a screen touch monitor, then the monitor would serve as an input device through which you can enter commands, and it can also serve as an output device through which information can be displayed. The central processing unit, which serves as the brain of the computer, and the main memory or random access memory are the main processing devices. The CPU is capable of performing arithmetic and logical operations. The CPU is the single most expensive piece of hardware in a computer. The power of a computer is dependent on how much data it can manipulate per unit time. That's the speed of the processor. The price of computers are usually dictated by its processing power. The main memory is also known as the random access memory, and it is connected directly to the central processing unit or the CPU. Before a program can be executed by the computer, it has to be loaded into the RAM. Also, before you can manipulate data with the computer, the data has to be loaded into the main memory or the RAM. The main memory is a temporary storage. It is a volatile memory. Thus, it loses its content as soon as the power is cut off. The main memory contains an ordered sequence of cells called memory cells. Now, each of the cells is identified by a unique location called address, and each cell is capable of storing a byte of data. So, for a system with a 4 gigabyte memory, there are approximately 4 billion of these tiny memory cells. The computer also has what we call the secondary storage. This storage is used for permanent storage of data and information. Now, secondary storage include hard drive, flash drive, CD-ROMs, DVDs, Blu-rays, etc. Secondary storage devices are not volatile like the primary or the main storage device or main memory. They are able to keep their content when power is cut off. When a program is installed in a computer, it is stored on the secondary storage. However, before it can be executed, it has to be loaded into the main memory by a program called loader. Input devices, as their name implies, are used to input data or commands into the computer for processing. The primary input device of the computer is the keyboard. Other input devices include the mouse, touchpad, scanners, etc. So, in effect, any device that is capable of feeding data or command into the computer is an input device. Output devices are also used to display the processed information or data. The primary output device is the monitor. Other output devices include printers, plotters, speakers, projectors, etc. The software aspect of the computer represents the non-physical aspect of the computer. That is the part that you cannot touch or boot, as my friend said. Software are programs written to instruct the computer to perform specific functions or tasks. Software can be grouped into system software and application software based on how they influence the computer's operation. Application software enables the computer to perform specific tasks. Examples of application software are word processors, spreadsheet programs like Microsoft Excel, browsers like Chrome, Mozilla, Edge, Internet Explorer, and gaming engines. System software can be grouped into operating system and what we call utility software. System software controls the computer. Without an operating system, the computer can do nothing. The operating system monitors the overall activities of the computer and it provides services to the application software. So the operating system sort of acts as an intermediary between the computer's hardware and the application software. The services rendered by the operating system include memory management, input and output activities, and resource allocation. Now, utility software include antivirus programs and defragmentation software. When a computer boots, the operating system is first loaded into the computer's memory, which in turn starts other application and utility programs. If the CPU is the brain of the computer, then we can as well say that the operating system is the computer's blood. The computer is very powerful. However, the only language the computer understands is machine language. Machine language is a computer programming language consisting of binary or hexadecimal instructions which a computer can respond to directly. Machine language is a sequence of zeros and ones. The digits 0 and 1 are called binary digits or bits for short. A sequence of zeros and ones is sometimes referred to as a binary code or binary number. Now, when a unique sequence of 8 bits is formed, it is called a byte. A byte is the basic unit of measurement in the computer world. Every character on the keyboard or command issued via mouse is encoded as a sequence of bits. The most common encoding scheme is the 7-bit American Standard Code for Information Interchange, aka ASCII. The ASCII dataset consists of 128 characters numbered 0 up to 127. For instance, if you take capital letter A, it is encoded as ASCII code 10000001, and this corresponds to 65 in base 10. Human beings use the decimal or base 10 number system. That is the reason we count from 0 up to 9. Computers, however, use the binary or base 2 number system, so the computer counts only zeros and ones. A programming language is a vocabulary and set of grammatical rules for instructing a computer or computing device to perform specific tasks. The most basic language of a computer is the machine language. Machine language, however, is processor dependent. That is to say that machine language is not portable. So if I write machine code for one processor, let's say 8085, I can't use the same code on a processor like 8086. Every processor has its own machine language, although some of the instructions are common among them. Programming in machine language is not an interesting thing to do. In fact, it is very tedious and error prone. So assembly language was designed to solve this issue. In assembly language, the instructions is an easy to remember form of mnemonics. However, a computer cannot execute assembly language directly. It requires a program called assembler to translate the assembly language program into an equivalent machine language. Although assembly language made the work quite easier, it was still a lot of work trying to remember all these mnemonics and thinking in terms of mnemonics. So high-level languages were introduced, and high-level languages are very close to our natural languages such as English, French, and whatever. High-level languages include Fortran, COBOL, Pascal, C, C++, C#, Java, PHP, Python, and the rest. Now, high-level languages may be interpreted or compiled. A language is said to be interpreted if it executes instructions directly and freely without first compiling it into the machine code. Compiled languages are generally faster than interpreted languages. Instructions written in C++, for instance, is much easier to understand and is self-explanatory. However, again, like assembly language, the computer cannot run C++ programs directly. To execute a C++ instruction on a computer, it has to be translated into a machine language equivalent. For assembly language, we use the program called an assembler. For C++, we use a program called compiler, which translates the instructions written in the high-level language into a machine code equivalent. To write a C++ program, one needs a text editor and a C++ compiler. Examples of compilers, C++ compilers include the MinGW, GNU compilers, Intel C++ compilers, CLang, Turbo C++, G++, etc. Most of these C++ compilers are proprietary. That means you would have to pay some money to acquire them. Notepad is an example of a text editor. In fact, every operating system comes with a Notepad program installed by default. You can use Notepad to write instructions in any programming language, so we usually refer to it as a universal text editor. However, if you are a programmer, you want certain activities to be easier, And writing code in Notepad is not an interesting thing to do. There are special programs called Integrated Development Environment, aka IDEs, that have been designed to make the programming experience an interesting one. IDEs include programs like compilers, text editors, profilers, debuggers that can usually be accessed by just a button click. In these tutorials, we will be using the DevC++ IDE. I'm using DevC++ IDE because it is very easy to use, it is not that complicated, and it is free. Other IDEs include CodeBlock, CLion, which you are actually free to choose any that you want. The instructions written in a high-level language is called a source code. The file that contains a source code is called a source file. Now, C++ source files have the extensions .h if it is a header file or .cpp if it is an implementation file. There are other variants of these extensions. Some of them include .cc, .C, .cxx, .c++, etc. Please follow the link and download the DevC++ IDE and install it before the next episode is released. You are free to use any IDE of your choice, but you are on your own if you come across any IDE dependent errors. Thank you for watching and see you in the next episode. Don't forget to like this video and subscribe to our channel. I am Professor and this is Tech Foundation.